Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 6 of GCP Zero to Hero series, and in this episode we will focus on virtual private cloud. So you will learn what is virtual private cloud, why virtual private cloud, what are the different components of virtual private cloud, and also how these components interact with each other. Unfortunately, a lot of people find the concept of VPC difficult. But trust me, after watching today's video, you will find VPC very, very simple. Because in today's video, I'm not going to explain you VPC through some definitions, but I will explain the concept of VPC by taking a real life analogy. All that you need to do is to make sure watch this video till the end. Perfect. Let's start with understanding what is VPC. To understand this better, let's go back to the concept of public cloud and quickly recap what is public cloud. We learned this in episode 1 that public cloud solves two major challenges with traditional IT. First is the maintenance challenge. If any company has to set up their own data center, or if the company is huge, if they want to set up multiple data centers, it comes with a huge maintenance effort. First, the company has to build a system administration team. Then they have to build these data centers. They have to procure servers from IBM or HP. They have to set up proper temperature, proper conditioning within the data center. This comes with a huge maintenance effort. And also timely, the system administration team has to patch the operating system of the servers. Second, costing. Again, if a company has to build this data center or multiple data centers, it comes with a huge costing for the organization. This problem is solved with public cloud. How? So public cloud providers like GCP or AWS or Azure. So instead of you setting up the data centers, what these cloud providers do across different regions of globe. So the public cloud providers have selected certain regions. For example, US East is a region, Central Europe is a region, APAC is a region. Within these regions, they have built multiple data centers. For example, in US, GCP has few data centers. In Europe, GCP has few data centers. And in APAC, they have built bunch of data centers. Now they take care of maintenance of these data centers. Only difference is that they share these servers across different companies. So instead of you building the data center, GCP builds these data centers across the globe, which are also called as availability zones. And the servers within these data centers are shared across different companies who onboard with their platform. Now, if your company needs a virtual machine, let's say virtual machine is of operating system Debian with 4 CPU, 4 GB RAM and 10 GB storage, you have to pass this specification to the API of GCP, and GCP, using the concept of virtualization, on one of the servers, it spins up virtual machine of your requirement. If it already has the requirement or the required virtual machine, it returns back to you. Otherwise, using the concept of virtualization, it creates a new one for you and it sends the information of the virtual machine back to you. So in this case, your maintenance is almost zero because you are not maintaining this data center. You are not even maintaining this virtual machine. Everything is taken care by the cloud provider. Second, costing. This will come significantly down because you will be only paying for this 4 CPU, 4 GB or 10 GB RAM or 10 GB storage because you are not procuring this server. You are not building this data center. You are not bearing costs of any of them. The cost will significantly come down. For cloud provider, because their usage comes to 90%, 80%, as they share the servers with different companies across the globe, they are also benefited. Because if individually someone buys the server, their usage might be 20% or 30%. Public cloud providers, they increase the usage by sharing the resources across different companies of the globe. Now, these are the advantages of public cloud. However, while this concept was widely adopted in the initial days, let's say in 2010, 2011, while this concept is being globally adopted, there is one loophole, or there is one significant drawback with the public cloud. That is security. Now, whenever maintenance goes down, whenever cost goes down, obviously security is also compromised. So this is directly proportional. Whenever you see, someone managing things for you, whenever you see someone reducing the cost for you, obviously they tend to compromise on the security for you. So this was one complaint on the public cloud providers, that security was less. Now, because there is this concern, again, public cloud providers like GCP, AWS, Azure, they came up with a concept called virtual private cloud. So virtual private cloud was introduced to address the security challenge of public cloud. Of course, these cloud providers might come up with different names for VPC. For example, in Azure, you call it VNet. In AWS and in GCP, you call it as virtual private cloud. Now, what is this virtual private cloud? It's a very simple concept. So if you take one of the availability zones, so let's say in the US region, in the US East region, in one of the availability zones, let's say this is 1A availability zone. So within this availability zone, you can request the cloud provider saying, hey, we need security. We are a banking company, so we cannot share the virtual machine, or we cannot have a non-isolated environment where our virtual machine lives with other virtual machine of some other company, right? Typically, that is what cloud providers used to do, right? So if this is a server, and if someone requests a server in EU, if this company is X, company X gets this virtual machine, on the same server, company Y might also get a virtual machine. Now, because of this, if this virtual machine is compromised, if there is a security breach, because the underlying hardware is the same and there is no isolation with the firewall, this virtual machine of X company can also be breached. What if this is a database? Then almost the user data of the company is compromised, which is a huge risk for the organization. So these challenges are addressed using virtual private cloud. As the name suggests, it's a virtual private environment. So within one of the servers, again going back, let's say US East as a region, 1A as the availability zone. Within this data center, you can request the cloud provider for a virtually isolated environment. So you can technically, if you want to logically understand it, out of this entire server, you can just request the cloud provider for a piece of server for yourself. And you say that this has to be logically isolated with some firewall settings, or this should be logically isolated from the other parts of the data center and other parts of the region of the cloud provider. So that even if one of the virtual machine here or one of the virtual machine here is breached, still there is a proper isolation which prevents the servers within your VPC to be attacked by the hackers. So you are still secure in the world of public cloud. So how can you or your company be secure in the world of public cloud? You can be secure if you go for a private cloud, which is called as virtual private cloud. The reason why we call it as virtual, because this is not a physical thing. you're not technically breaking this server into two parts, but you're logically isolating a part of this server, or maybe um, part of different availability zones using the concept of VPC. Different cloud providers have different ways of handling the concept of VPC. In the world of GCP, let's say you choose a region. Again, going back, let's say you choose APAC, and within APAC, let's assume there are only two availability zones. Of course, there are many, but let's say there is Mumbai as one of the availability zones, and let's say there is Delhi as other availability zone, right? Now, if you request for a VPC, this VPC, again an isolated one, is spawn across the different availability zones of the region. Now, you might be confused, but remember, this is a logical one. You are not physically breaking this, you are not physically breaking this. So you get a logical environment across different availability zones of the region. So this availability zone lives in Mumbai, this availability zone or this VPC lives in Mumbai, this VPC lives in Delhi, and other availability zones of the region. Perfect. So this is the concept of VPC. But Abhishek, how does this work? Like, how do you logically isolate and how do you secure a VPC? What are the different components of VPC? Like, I have heard of subnet, I have heard of firewall, I heard of something called routes, load balancer. What exactly are all of these components? We'll do one thing to simplify this. To make it further easy, let's take an example of a society. Imagine a town. Let's say there is a huge town, a fast growing one, and bunch of people residing in the localities of the town. A real estate person called Ram saw an opportunity. So Ram saw that there is huge vacant land within the town. So Ram decided to buy a piece of land within the town and build a secure society. Maybe build bunch of villas and sell them to people in the town and even people outside the town. So Ram started with a simple calculation. Okay, so I'm going to build 100 villas. Maybe I need 50 acres of land. Now with this calculation, Ram started building the compound of this society. So to make it secure, maybe Ram started building the concrete walls, electrical fencing, so that this is secure from the neighborhood as well. But of course, some people might also enter the society. Maybe the people residing in the society, they can talk to each other, but they also expect some guests. So Ram built a gate at the entrance of the society. Let's say this is a gateway through which people can enter the society. Any external person who wants to communicate with people in the society should pass through this gateway. Now, obviously, this is a huge piece of land, 100 acres of land. This has to be used in an organized way so that this can be used in a best way. So Ram decided to break this into blocks. So Ram said, this is going to be block 1, maybe an elite block. This is going to be block 2. This is going to be block 3. And this is going to be block 4, maybe for recreational or a play area, which can be used by everyone within the society. Now, of course, these blocks should also be of a defined size. So again, Ram calculated maybe within each block, I might build some 35 villas. So each block should be of 15-acre size, or maybe each block should be of 10-acre size. So this is 10 acre, this is 10 acre, this is 10 acre. This might be 5 acres and 15 acres is the common place. Perfect. Now, obviously, anyone who tries to enter the society, or even let's say there is a villa here, and this villa wants to access swimming pool in the recreational block. Now, how do this person in the villa know swimming pool is here? So to make it simple, Ram set up directions and paved paths within the society or paved roads within the society. So there is a road that connects block 1 to the swimming pool of block 4. Or maybe because this is a common area, anyone or any guest that enters the society, they might first wait here for the guests if the guests are not in the place, or they might just sit in the lobby. So gateway is connected to this block. Similarly, as I told you, this block is connected to this block, so people can uh, meet each other. So there is a road that is set up, or there is a route that is set up. Similarly, this block is also connected to this block, and because this is a recreational block, all the blocks are connected to this particular block. So typically what I'm trying to say here, Ram has set up directions and also paved roads within the blocks or within the society. Let's call it as route. Of course, anyone should not, like, let's say if this person, a guest is approved to enter the society, maybe to meet a person in Villa 101. So this person should not enter and go to 201 because it can be a security threat. So because of that, a proper security is also maintained within the society. So the step 1, if an external person wants to enter the society, and let's take this scenario, wants to access villa number 101, what are going to be the steps? Understand this carefully because this will highly relate to our GCP VPC example. Now the first step, so this person should know where is this society, because this is a huge town as I discussed. So first this person use the Google Maps, probably enter the address and figures out, okay, so this is here. So this is the location. So step 1 is Google Map resolves the location to an address. Perfect. Now this person is here, but obviously to enter the society, let's say this person does not have any bad intention. So this is a authorized person. So this person pass through this gateway, cannot enter from here, cannot enter from here. The only way is to enter through this gateway. Okay, so this is step 2, the gateway. Now this person can enter and access only this block, because this person cannot jump onto the block 3 or cannot get to block 2. This person can only go to block 4. Perfect. Now once this person goes to block 4, maybe waits here in the lobby, or if 101 is already in the villa, so this person looks at the route, understands the direction, and heads to this particular block. Now once this person enters the block, obviously there is 102, 103, 104, and this person cannot get into any of the villas, because as I told, there is a security guard here, and this security guard blocks the access, or maybe there is a gate security which blocks the access. Now this person finally goes through the internal route. Again, there will be a route within this block. Through the internal route, this person gets into 101. So this is the typical journey of someone who wants to enter the secure society. Now let's try to correlate this with GCP VPC. It is going to be exactly the same because the concept of secured society is same as the concept of virtual private cloud on the cloud providers. So now in this case, a cloud engineer or a cloud architect decides to set up a VPC within the cloud platform, right? Just like how Ram decided to set up a secure society within a town. So in this case, cloud provider or cloud architect decides to set up a VPC within the cloud provider or within the cloud account. But Abhishek, how will the cloud architect decide the size of the VPC? Obviously, VPC also has a size, but this size is calculated in IP address. So the size of VPC is defined by number of IP addresses. So what a cloud architect does, so cloud architect starts calculating number of applications, number of resources, number of databases that might go into this VPC, considering n number of teams which are going to use this VPC, and says, okay, so this is going to be the size of my VPC. And this size is calculated in a terminology called CIDR. For example, cloud architect says the size of my VPC should be 172.16.0.0/16. If you're not sure how CIDR is calculated, I have made a detailed video on it. I'll put the link in the description because it will shift our focus in a different direction. Let's not get into it. But what I'm trying to say here, so typically cloud architect understands the size of the VPC by looking at number of applications and resources within the VPC. Now this means it's going to be 256 times 256 roughly. Perfect. So once the size of the VPC is decided, just like the example of real estate, now this entire VPC cannot be used by a single team. Of course, it can be used by single team or single application, but applications might talk to each other. A team might want to talk to the database of the other application. So VPC might be set up for bunch of teams or a particular project in the organization. Now within this VPC project, so cloud architect decides, let me break this into multiple blocks. Now in this case, blocks are called as subnets. Okay. Now again, if you understood the IP address and CIDR concept, so again when VPC is split into blocks or VPC is split into multiple parts, Cloud Engineer decides the size of the subnet using CIDR. So maybe this CIDR can be 172.16.3.0 followed by 8. And similarly, there can be a size for this subnet as well. There can be a size for this subnet, and there is another subnet. Maybe we call this as a public subnet. Just like how there is a recreation area, which is a common one, or people who enter from outside access this block. Similarly, there can be a public subnet within the VPC. But Abhishek, what is this public subnet? What is this private subnet? Very simple. Just like how there is a gate for the society, when a VPC is set up, an internet gateway is set up for the VPC. So any user who tries to access applications within this VPC, they have to pass through this gateway. Now, once they pass through this gateway, if there is an application that can be publicly accessible, so this application should be passed through this gateway. Sorry, the request should be passed through this gateway. Very simple. There can be a front-end application, or maybe there can be a load balancer, which should be publicly accessible. So that is placed within the public subnet, and users through this internet gateway access the load balancer. This is not at all new. Today, when you use Amazon.com, when you use Swiggy.com, Uber Eats, Uber.com, they are all load balancers and they're all placed in the public subnet. So users through the internet gateway access that load balancer. Now, but Abhishek, how is a subnet made public? Like, how do you say that this is a private subnet and this is a public subnet? Very simple. Now, when a VPC is set up, just like directions and roads within the society, a real estate society, similarly, when a VPC is set up, the cloud architect defines something called as routes. And the directions within the routes are basically called route tables. So routes and route tables. So if the route is connected to the internet gateway, or if the destination of the route within the route table is connected to the internet gateway, then this is called as a public subnet. Quite obviously, right? Because internet gateway allows public access. So this becomes a public subnet. Now these can be private subnets. So there can be connection between the subnets through some routes and through some route tables, but they are not connected to the internet gateway. So these becomes private subnets. Now the meaning of private subnet, any application, let's say you place a database here. This database can be accessed by application here, or this database can be accessed by application here, but cannot be accessed by people outside the VPC. Okay, so learned there is something called routes or routes, and there is something called route table, which defines directions, or which defines the routes within the subnet and also outside the subnet. Just like how you have roads within the block and also outside the block. Now, what does the user journey look like? Now, when a user, let's say this is the VPC of Amazon.com, or this is a VPC of Uber.com, just for example. Now, when this person tries to access Uber.com, as I told you, first request goes to the load balancer. Now, load balancer is here in the public subnet. So what typically happens? User, as the first step, enters Uber.com in the Chrome or Firefox browser. Now, this is where Google DNS comes into picture, and this DNS, so the request is taken by the DNS and it resolves Uber.com to the IP address of the load balancer, or maybe to the DNS name of the load balancer. Now, because it is connected to the internet gateway, the request will flow through the internet gateway and it is sent to the load balancer. Now, the load balancer can forward the request to a backend application or maybe a front-end application. Imagine the request is sent to a backend application. This public subnet also has a route to the private subnet. Typically, wherever you have the load balancer, it is connected to the public as well as private subnet. So now the request goes to this public subnet, and from this public subnet, again through a route and direction suggested by the route table, the request is sent to this application. Let's say this as a backend application. And from the backend application, it can be sent to the database. And again, from the same route, request is sent, response is sent back to the load balancer. And from the load balancer, response is sent back to the user. So this is how the user journey would look like. So the first component is Google DNS. Then the second component is the load balancer. In between, the request goes to a particular subnet. We call it as a public subnet because it is connected to the internet gateway. And from there, through routes and route tables, which defines the direction, request goes to the backend application. And from there, response is routed back. So this is how the components of VPC work with each other. But Abhishek, what if load balancer, or what if there is a malicious user through this internet gateway tries to access an application which this user should not access? Don't worry. Just like how there is a security guard, each application within a VM instance can also be secured through firewall configuration. So the cloud architect or cloud engineer designs a firewall for the VPC, and then this firewall can be attached to n number of virtual machines or VM instances. So security is taken care by the firewall within the VPC. Now let's try to understand what are the different components we learned. You'll be surprised. We have learned a lot of components till now. First of all, we learned VPC. Obviously, what is VPC? VPC is virtual private cloud, where you are setting up an isolated environment within the cloud platform. And the size of the VPC is defined by CIDR block. So this defines number of IP addresses within the VPC, which is the size of the VPC technically. Then we learned about subnet. So what is a subnet? Subnet is a part of the VPC. So if you want to break your VPC into multiple parts, you define subnets, and again you define the size of the subnet using CIDR. Obviously, calculation of the IP addresses. And a subnet can be public or private. But how do you define if a subnet is public or private? Very simple. If the subnet destination or the route table destination of the subnet is connected to internet gateway, then this becomes a public subnet. What are the components you typically put in the public subnet? Maybe your front end, or if you want to secure your front end, you put a load balancer, and that load balancer will connect to your backend or database applications. Typically, anything you want to allow external access is placed in the public subnet. Then we learned, after public and private subnet, we learned about routes. What are routes? Route defines the directions, or route defines access within the subnet and also access outside the subnet. And this is done by route tables within the subnet. So route tables explains the direction. Along with that, we also learned that there is firewall. How do you preserve access to a VM instance? When you place it in a public subnet or when you place it in a private subnet and you don't want everyone to access it. Probably you want to disable SSH access to an instance, or maybe you want to disable HTTP so that you only allow HTTPS access. That can be done using firewall. So you set up firewall within the VPC and you assign the firewall using a concept called tags, which we will learn in the next lectures. Perfect. We learned about 1, 2, 3, 4, 5, 6, 7 different components, and these 7 different components along with the load balancer and internet gateway are very important within your PPC. There are also other components. We will take another 2 minutes to learn about these components. When we do these things practically, you will be more you will understand more about these components. But there is something called NAT. What is this NAT? Now there are many cases where one of your applications in the private subnet might want to talk to the internet, right? Maybe one of your applications in the private subnet wants to talk to an external application to retrieve a JSON. Perfect. So in this case, or maybe one of your application wants to talk to a third party application to download a dependency. Now, in this case, if this application directly talks to a third party application, this third party application will understand the IP address, which is a security threat. Now, to avoid this, a component within the VPC called NAT is placed. NAT. This is not a GCP concept. NAT stands for Network Address Translation. What this does, your request is sent to NAT. NAT changes the source IP address. So it places the source IP address as the NAT address so that this third party application thinks request is originated from the NAT, or request is originated from this particular point. Even if this is a malicious actor or even if this is a hacker, this hacker tries to hack the NAT and would not get anything related to your application. So this is called as a network address translation. If you find it complicated, don't worry at this point, but understand there is something called NAT for securing your application. Now, finally, Abhishek, within my organization, I have set up this VPC. I'm a cloud architect. Now I want people in the organization, someone who logs into the office network, they should directly able to connect to this VPC network, because this VPC network is a private network. And in my office, we use the Wi-Fi network within the office. How can we connect the office network with this VPC network? So for that, the concept. So the concept that we use is VPN, which many of you use on day-to-day basis. VPN to connect to a secure website, or maybe VPN to connect to something that you cannot access in your country or in your region. So the same concept we use. So we use the Google VPN to interact with the VPC if you want to connect that to your corporate network. Very commonly done by the cloud engineers. So cloud engineers set up the corporate network and integrate the corporate network with the VPC so that people can log into their office network and directly access the instances or directly access the database within the network. So these are different components of VPC. I hope you understood through the secure society analogy. If you have any questions, do let me know in the comment section. We have episode 7, episode 8, where we are going to do most of these things practically. We are going to use a 3-tier architecture application, or at least 2-tier architecture application. We are going to use a load balancer, and I'm going to show you how a VPC is created, how the subnets are created, and how applications are placed and accessed through the load balancer. If you find this video interesting, please share this with Google Cloud enthusiasts that you know, or anyone who is preparing for the certifications. See you all in the next video. Take care. Bye bye, everyone.